Good morning, class. Today's topic is when an electric charge is placed in a uniform electric field, then what happens? Then we will extend when an electric dipole is kept in a uniform electric field, then what happens? So let us begin with the uniform electric field. Let its intensity is E, and recall that it is given by F upon Q. Now this electric field intensity is along the direction of the force, and this Q is the charge which is experiencing this force F, or the charge which is kept in the electric field. Now if let Q is equal to 1 coulomb charge is kept, then this E comes out to be equal to F. So the electric field intensity is force on 1 coulomb charge. This is the simplest definition. Electric field intensity is force on 1 coulomb charge, or we can say that E is rate of force on a charge. Suppose there is 5 coulomb charge Q1 plus 5 coulomb charge. So force on this 5 coulomb charge Q1 will be equal to 5 into E. So in place of Q, now this is F is equal to Q into E. So 5. Now if here Q2 is minus 5 coulomb charge, then force on Q2 will be equal to minus 5 into E. Means the force will be opposite to the electric field. So these are the two key concepts. So now we represent electric field, uniform electric field by parallel lines. And if we write E is the intensity, means at every point of this field, the value of electric field intensity is E. Means if we choose any point anywhere in the field, the value of the field will come out to be E. So the value and the direction also, direction is along the direction of the arrowhead. Same everywhere inside this region. So this is uniform electric field. So if the charges are kept in electric field, suppose here, now let me place a charge Q here. So since electric field intensity is E, that is the rate of the force, then force on this charge will be along this direction. If we place a charge minus Q here, then the force will be in opposite direction. See here in this example. So force will be along this direction, opposite to E. Opposite to E. Now in case of positive charge, force will be parallel to E, or along the direction of E. So positive charges plus Q charges experience force parallel to electric field, and minus q charge experience force anti-parallel to electric field. So these are the two things to remember in memory. So let us begin with the thing. We know that if this charge is free, if these two charges are free, then since force is acting, so there will be an acceleration. If the mass of these charges is m, then there will be an acceleration, and again the acceleration will be along f, along the direction of f. The direction of acceleration will be along the direction of f. So acceleration on the charged particle, acceleration on the charged particle A having mass m will be given by F upon m. Now F here is Q into E. F here is Q into E. Q charge is kept here in the field. Q charge is kept. So the F is equal to Q into E. Again this is minus Q into E. So now the acceleration is F upon m, that is QE upon m in case of plus Q charge, and the acceleration will be minus QE upon m for minus Q charge. So let us begin with the positive charge. Acceleration is this one. Now think that when there was no field means the value of electric field is 0. Then at that time, having mass m, charge q, the force was 0, and again the initial velocity was 0. But when field is applied, means now the value of the electric field is not 0 but applied along this direction. So the charge will experience a force Q into E along this direction. So we'll have acceleration along this direction. So now this will start moving. So let from u is equal to 0, let it begins moving along this direction and gains a velocity v after tau second. Then the velocity v after tau second can be found using first equation of motion, at. So here v is v, u is 0, plus acceleration, we have the value of acceleration, and in place of time there is tau. So v comes out to be acceleration, the value of acceleration here we have calculated, QE upon m into tau. This is the value of acceleration is equal to QE upon m. Again the velocity will be gained along the direction of acceleration. So the velocity along this direction. So this is the expression of velocity in terms of electric field. Again, let us suppose that this charge, the charge from u is equal to 0 to v is equal to E upon m into tau. It gains the velocity in t seconds, tau seconds. And electric field is along this direction. Now this is the situation. Let this distance is d. Distance traveled by the charged particle in tau second is d. And we know that there will be potential difference. Now let this is point A, this is point B. So there will be potential difference. VA minus VB, potential difference at these 2 points. Let us call it V. And this potential difference is between D distance. Distance kitni hai? Distance is D distance. The potential difference is acting in D distance and electric field intensity is E. So what is the relation between these two? That is electric field intensity magnitude. Actually it is negative gradient of potential. So here E is dV is now, this is dV, delta V, dV. So here it is V and the distance at dr is small d, and if we find the magnitude then it is E is equal to V upon d. So in this expression in place of E we can put V upon d. So the velocity comes out to be V is equal to Q upon m. In place of E we will put V upon d into tau. Now if there is positive charge or negative charge, so we can put it like that. Sorry, negative gradient of potential. Sorry, then velocity will be equal to Q upon m V upon d into tau. Now this velocity will be along the direction of the electric field. So now this gradient is a vector quantity. This d upon dr is a vector, not potential. So don't put sign here on the potential. I misunderstood as it has another thing. So potential difference V, this is the potential difference V, and this is the velocity V. So velocity is along the direction of the field. So this is the velocity we have find here. Also we calculated acceleration here at this point. The force is along this, force, acceleration, and this is finally velocity.